talk you through what it is you've done. This is partly for the benefit of people not here, but also for you guys that are in the room. So we've today created some data. We had weak acid in a beaker, and we added strong base to it, strong alkali to it, to generate a pH curve. And if you weren't here, there's the data that you can copy up. There's a sheet somewhere with your name on it. Come find a sheet, and then you can get your own data. Next lesson, I'll tell you what I want you to do with that data, but not now. Right, we're going to be talking about titration curves for these next sort of 5-10 minutes or so. And I'm going to remind you, you've already covered titration curves a bit. What you've covered with titration curves so far, I did a very similar practical last year with Mr. Craig, where you generated the titration curve using probably, I'm guessing, strong alkali being added to strong acid. So you probably had strong acid in the pot, and you added strong alkali to it, and you'd had a pH curve like this. You have pH on the vertical axis and volume of hydroxide on the horizontal axis, and you'd had a titration curve that looked something like that. Okay, and the key features of that graph were that you had a vertical region that's usually at least 2 to 3 pH units, and then in the exam, this is more A-level-y than IB, but when you're drawing these, sketching these, you have to have a vertical region, and there has to be a couple of pH units. So they're really fussy about that at A-level, so it's worth mentioning now in case the same thing comes up. And when you're sketching these, please make sure it's very easy. I'm going to draw a bad one here. It's very easy, and I've marked this kind of stuff before. Do that, and it sort of tails off. That loses a mark. It's so easy to lose a mark, and you see why. It's just tailing off at the top. pH, of course, can't come down at the end there when you're adding hydroxide. So that an examiner would knock a mark off for that sketch. So it must be like this. The volume, when you've added the same number of moles of acid and alkali, is called the equivalence point. So that point there you learnt last year is called the equivalence point. It's not necessarily the neutral point, okay? We'll talk about that. But for a strong acid, strong alkali, the center of that vertical region, which is at the equivalence point, will be pH 7, right? So it would be a neutral point. The equivalence point, by definition, is when you've added the same number of moles of acid and alkali to give you a salt and water. Before that equivalence point, the pH would be less than 7, and above that point, the pH would be significantly above 7, and you get this vertical region in between, right? So that's what you did last time. I think there's anything else from that. Anyone want to check anything about that? Okay, so that's for a strong acid, strong alkali that you did last year. Now, what you've done today is you've generated data which, when you draw the graph, will look something like this. So if you can make a note, this is strong alkali to weak acid. And there are some key features to this graph you need to know from memory and be able to produce in the exam, like sketched features. And that's what we're going to talk about. We're going to talk about it in detail in time as well, a bit more next lesson. So again, you've got pH over here. Again, you've got volume here. And we're starting, rather than pH 1 and 14, which it was there for that graph at the top, 1 and 14, or 1 to 2 and 13 to 14, this time the pH of the weak acid will be around about 2 to 3, often about 2.5, 3, something like that. So we're going to start at a higher place. So if you're sketching this, you need to know that's probably going to be about pH 3 you're starting at. It might be you have to work that out from information given. It might be you have to work out the pH of the weak acid from what we did earlier in the topic, which is learn how to calculate the pH of a weak acid from its concentration times by its Ka. You take the square root of the concentration times the Ka, gives you the hydrogen ion concentration, and then convert that to pH by doing minus the log of the hydrogen ion concentration, right? So that's what we did before, and that pH for the acid you've just used, ethanoic acid, would be about 3-ish. Now what you get is, when you add the alkali, you normally get a little sharp bit right at the start, and then you get this very steady upward slope, okay? It's kind of like a cyclist's worst nightmare, this long, continuous, very gentle, but continuous slope up until the equivalence point. And I've stuffed this up a little because I've written there, but you can make that right, that's okay. So that's still the equivalence point. That's still the point at which you've added the same number of moles of acid and alkali. but there's some features to this graph I want you to highlight now. So the equivalence point is still the equivalence point. The pH at the equivalence point, we'll discuss in a minute. But this region here, and we'll discuss this again in a lot of depth, is what we call the buffer region, where the pH is climbing very gently as you add the alkali. It's not climbing sharply, it's climbing gently. And the buffer, we perhaps know from biology, is when you add small amounts of acid or alkali, pH doesn't change much. It changes a little bit, but not very much. We'll learn about why and how that works and do some calculations with it in due course. Now, at the equivalence point, you've got equal number of moles of acid and alkali, which means they cancel each other out. They're gone. There's nothing, none of that left, none of that left. You've generated a salt, right? Now, if this is the salt of a weak acid and a strong alkali, we learned in a lesson or so ago whether the pH of that salt is going to be acid or alkali. Now, the way I asked you to think about it was, think about it from the tug of war analogy. Strong alkali, weak acid. What's the pH of the salt going to be? 3, 2, 1. The pH greater than 7 or less than 7. 3, 2, 1. Yeah, okay. So that we can remember, but the explanation for that is usually a bit tougher. There's a couple of ways of remembering it. One is the fact that it's the kind of tug of war analogy: strong alkali, weak acid. The salt is slightly alkaline. Also, we call it a conjugate base, so maybe that's a clue as well. What is it that makes it alkaline, though, please? And this is where you're going to get the marks at IB. What does it makes it alkaline? Discuss. What's it going to form to make it alkaline? What's it going to produce? What's the ion that makes things alkaline? What's the ion that makes things alkaline? You had no one to talk to, you can tell me. That's what makes things acid. OH minus. So we generate OH minus because the conjugate base bit, the sodium ions does nothing, but the A minus bit, remember, of the conjugate base reacts with water to generate hydroxide and HA. But it's the presence of this thing causes the pH of the salt to be slightly above 7. So at the center of that equivalence point, that vertical region, all you need to know, you need to annotate this on your graph, this has got to be a pH greater than 7. You expected absolutely to know that, okay? And we'll talk about other, there's a few different versions of these graphs, we'll talk about all of them, you can work them all out. So there's strong acid added to weak alkali, or to weak base, sorry, it's exactly the same but in reverse, it's just upside down. So we'll cover all of that stuff. And if I'm honest, that's probably driving me crazy. So that's probably all I want to cover. I think it's probably a good place to stop. I think that's where I got to with the other group. So I'll stop it there, and then I'll tell you that you are going to draw this graph. I'm not going to expect everyone to have done it by tomorrow because I forgot to tell the other group for a start, and there's a couple of people not here. If you want to get it done tonight, you can do. It'll end up looking like that. It'll end up looking something like that, and we'll talk about something important about there next lesson. We'll cover that next time once we've learned about buffers. Okay, so if you make sure everything's packed away, get yourselves organised, and we'll head off fairly soon. Thanks.